Tuesday's lecture before we get too far into this. Okay, so again, sweating copper pipe is one way of joining copper. The second means, which is still relatively new on the market, is press type fittings. A number of different manufacturers have their trade names. I think this one listed here might be called ProPress, but you see that press type fittings are a combination of specific fittings and then a tool that's used. This tool actually squeezes or presses the joints together to form that bond. The other way that we can join copper pipe, especially if it's a smaller diameter connection, would be with a compression fitting. So this is a combination of a nut and this little sleeve or ferrule. Again, you're not going to do that with larger pipe, but you might do it with a small 1/2 inch or 3/8 inch piece of copper, especially maybe a flexible connection that's leading up to your final connection to a fixture. So that's copper pipe. Another material that we can use in plumbing is galvanized steel piping. A couple advantages here. Obviously, it's a strong, stable material. That galvanizing or coating is what prevents the pipe from rusting. We have a number of different grades or weights of galvanized steel pipe available. Standard, extra strong, or double extra strong. Typically for residential or light commercial, we're just going to use standard weight galvanized steel pipe. So what is galvanizing? Galvanizing is the process of putting a protective coating made from zinc onto that steel pipe. Good evening, Vaughn. Thanks for joining. We're just getting going here on Unit 13, talking about different kinds of piping materials used for supply piping. We just jumped into galvanized steel. No worries. So again, galvanizing is putting that zinc coating on steel pipe to halt or prevent the formation of rust. Obviously, nothing lasts forever in term, including galvanizing. So it's long-lasting protection. Obviously, not forever protection, right? Nothing's forever, right? How do we know galvanized steel pipe from plain black pipe? It's going to have this. It's actually a little bit of a dull gray color. It's not really a shiny silver, but more of a dull gray color. Right, so there's our pipe. Sorry, this is a little hard to read here, but again, this will be just like we saw with different types of copper piping. Schedule 40 is standard galvanized piping. Schedule 80 will be thicker, right? Has the same outside diameter and an increased wall thickness. So obviously the ID or the inner diameter will be a little bit less. Same as we saw for different types of copper piping. So along with galvanized steel, we will have various types of fittings. And yes, we have Schedule 40 in PVC as well. So the terms Schedule 40 and Schedule 80 will be applied in both galvanized steel and PVC. Good question, Vaughn. You'd have to look to see exactly what the ODs and wall thicknesses and IDs are of the two materials, because they will differ slightly. But yeah, it's the same kind of thing. Schedule 80 will be a little bit thicker wall. than Schedule 40 in both galvanized steel and PVC. So again, with galvanized steel, just like copper, we'll have these, kind of purpose-built or made-up fittings, and we will also have short lengths of pipe that are pre-threaded on both ends. This is called a nipple. So typically, if a plumber is coming to do a project at your house or doing a commercial project, they will probably have these things called nipple trays. So they'll have a series of short lengths of threaded pipe called nipples, made up in various lengths, already pre-made for them to speed up the process. Right, with galvanized steel, we are screwing pipe together using pipe threads. So again, you see the threads on our nipple, and you also see the thread on the length of pipe. So again, you may have the pipe already pre-threaded, or if not, then you have to use a tool to put the thread on the pipe, either a hand tool or a electric tool. And again, you'll have various, for different size or different size ranges, you'll have a different fitting that goes into the tool that cuts the thread into the pipe. And then we have a thread sealant typically called pipe dope. If it looks like this, or this stuff here is typically called Teflon tape. So actually what you're doing is you are lubricating the thread. So the pipe dope or the Teflon tape is not what's actually doing the sealing, but it's lubricating that joint so you can screw it in tighter and provide a tight joint. Aside from copper and steel, which we just talked about, we can also use plastic pipe in plumbing installations. Again, it's going to be, as Juan pointed out, rated in terms of wall thickness, and also whether it's rated to carry hot water or not, whether it's PVC or CPVC. And we can join that plastic pipe by threading or solvent welding. Typically, plastic pipe will be solvent welded, as we'll see. A couple different types of plastic pipe that are possible. And again, I'm on Unit 13, talking about different piping materials on page 231. In this case, myself and the other instructors, we've added some additional material in this lecture over and above what we got from the textbook manufacturer. So we've tried to build it out and provide a little bit more information to you. So again, we have PVC or polyvinyl chloride, typically used for cold water and sewage or drain, waste, and vent piping. We have CPVC, can be used for cold, but we need it if we're going to have hot water in our plastic pipe. It has to be CPVC. We can also use PEX or cross-linked polyethylene, which is a flexible plastic tubing, or ABS. Again, I use a little bit of a tongue twister sometimes to explain what all the materials are that go into the various types of plastic pipe. Again, here is examples of PVC and CPVC. And that pipe will be rated with its size. Right, here's 1.5 inch, Schedule 40. This one says DWV, which is drain, waste, and vent, which we'll get to in just a minute what that means. It's pressure and temperature rating. Right here's half-inch Schedule 40 PVC or half-inch CPVC, which will say hot and cold water. Again, same as we, analogous to what we saw for copper and for galvanized. We have Schedule 40, Schedule 80, or even Schedule 120, right? So again, the higher schedule number means a increased wall thickness, but depending on the service, we might need that heavier wall thickness. Say if that's the pipe that's going to be underground, like we saw in stage 1 of our plumbing installation on Tuesday. Some examples of fittings. Again, elbow 45T. That looks like an end cap, a reducer or an increaser, depending on which way you're going. So how can we join plastic pipe? Typically, what I'm most familiar with is what's called solvent welding. So we're actually using a solvent that forms a chemical bond with the plastic. Oh, sorry. Thought I had another picture. Again, the solvent is brushed on and the pipe is put together. The solvents usually stink like hell, so you often, if you're doing this at home, you want to do it with the windows open. I thought I had a picture. The solvents oftentimes will be purple. So once you're done with the solvent welding, you might have some purple sticking out of the joint, or some purple dripping onto the floor from your solvent welded connection. Some information here on how we size piping. Again, if it's a relatively straightforward residential project, the plans will just say what goes where and leave it to the plumber to decide how to size that piping. If it's a more complex commercial project, the architect or someone on the architect's team will do that pipe sizing and call that out on the drawings. The mechanical engineer will do that pipe sizing. But again, one way of sizing piping is with this fixture units, or in the case of water supply fixture units. So different types of fixtures will have a number of units associated with them. And going along with that will be a table that says how many fixture units a certain size pipe will support. This pressure range would be, what's the pressure coming in from the city? What's city water pressure? Right, obviously with more city water pressure, or more kind of oomph or motive force on the piping, we can move more water through a given length of pipe. So again, this would be a combination of fixture units and length of piping. So again, if you were so inclined, you could figure this out if you're doing a plumbing project in your house. Again, for a straightforward residential project, the plumber or plumbing contractor will generally do this work. If it's a more complex commercial project, then pipe sizing would be done by the design team, by the mechanical engineer. Right, so we have plastic pipe that we can use for water supply, as we just saw. We can also use plastic pipe for the DWV, or the drain, waste, and vent. We'll see what drain, waste, and vent means in a minute, right? Domestic, the water supply or domestic supply is the hot water or cold water coming to the fixture. The drain, waste, and vent are the wastes being conveyed away from that fixture, as well as the vent, and we'll see the function of the vent in just a minute. But the key to DWV piping is that DWV is not carrying the same pressure that supply piping is carrying. So DWV piping does not have to have the same wall thicknesses or ability to handle pressure that domestic supply piping does, right? We are, our domestic supply, if we have, may have to take 50 pounds of pressure from the city. Obviously, in the DWV piping, we're only subject to, any head from gravity, so we have much lower pressure requirements in DWV piping. Again, here's our picture. Here's 2-inch Schedule 40 DWV. So don't try to cheat and use that DWV piping for your supply piping, because you could easily run into a situation with a failure of that piping if the pressure exceeds the pressure rating of the pipe. Again, DWV piping will have specific fittings associated with it. Those fittings will look a little different than the fittings on the domestic supply side, primarily because we're looking to, connect this piping up in such a way that it conveys the waste downward and out to the sewer. So in our sewage disposal system, or our DWV system, we will typically have a vertical soil stack. We'll have a vent. Each fixture will typically have a trap. And in the system, we also need to have cleanouts, right? We need to have a way for the plumber to get in there with a rod and clean things out if the soil stack gets clogged up. Right? Cleanouts are there for servicing, right? Either as the homeowner or in a commercial. Give somebody a way of keeping that piping system clean and able to do its function. Right, so here's kind of a visual of what the various parts are of a DWV system. Right, each fixture, either in the toilet itself, you have you have water in the trap of the toilet, or at each fixture we typically have this little U-bend, right? So, look under your sink or in your lavatory or in the basement, and you're typically going to have this little U-bend in the piping. That U-bend is a trap. That trap should be wet. So that trap is meant to prevent the sewer gases or the smell from being drawn into the house, right? Sometimes that, let's say if you're going on a long vacation, that trap could dry out and you come back from vacation and, well, wow, how come my basement stinks? Well, the basement might stink because that trap dried out. So again, we have the vent system, right? Vent system allows the smell of the sewer gases to go up. and allows air to be brought in, right? So as the waste goes down, that air is brought in, and having a source of air from the top of the vent prevents us from pulling air in through the traps in each fixture. So again, the idea here is to let the waste go down to the sewer, and with the vent in the trap, keep those smells away from the folks in the house. And again, here's our clean out. Right, clean out would be our provision someplace to rot out that section of drain line if necessary. There probably should be a clean out here at the base of the soil stack as well. Again, if you in my house, we have cast iron DWV piping, and at the base, kind of hidden in the basement, there's a special fitting, cast iron fitting that has a little portion on it that you can screw open and again get in there and rod that piping out if necessary. Again, we have an analogous method to sizing the waste piping. We have DFUs, or demand fixture units. So again, as you go along, you'll add up DFUs. As you progress downward and outward, obviously the DFUs increase, as does the pipe size. Again, just like on the domestic side or the supply side, for a straightforward residential project, this sizing will be left to the plumber or the plumbing contractor. The plumbing contractor probably knows what to do by rules of thumb, or they go through this analysis. For a larger project, commercial project, this would be done again by the mechanical engineer. Again, some examples. Some of these are a little hard to read, but I tried to, when I made these slides up, tried to put some pictures in here to help you kind of visualize what that DWV piping looks like. And again, generally speaking, you're not going to see it, right? You'll see what's happening. When you open up the vanity in your bathroom, you'll see what's happening with that trap. If you look outside, you might see the vent sticking out of your roof with the flashing around it. But a lot of this stuff is going to be buried in the wall. Yes, Ayana. And I'll get to you in a second, Christoph. Go ahead, Ayana.
You know what? I was just gonna ask, like back on that last slide, was that similar to I don't know what, I forgot, was it the Sullivan House where it had that one bathroom that was like a possible bathroom that was gonna be in the basement, and maybe so they would have prepped the walls with all of this DWV piping, and then just left it for, I think it was like when the owner might put a bathroom down here, maybe.
Yes, that's correct. I'm guessing what they would have done in Sullivan, this soil stack would be there already, right? Because the soil stack would have been there to serve the fixtures that are going to be installed. I believe what they did is they would have put in the stuff below the slab and stubbed it up for a future connection. I believe that's what we saw in Sullivan. I think we have the same thing in Marseille, and we will probably get back to we'll get back to Marseille here on activity 13-1. So yes, good catch. Yeah, it was roughed in for the future, right? So if the homeowner decides, hey, I want a half bath in the basement, a couple of years down the line, provisions have already been allowed for it, right? They don't have to jackhammer up the basement slab to make those connections.
Okay, got you.
Christoph, is there a reason roof vents are used instead of a trap beneath the cleanouts? Plumbing is not my forte, Christoph, so I'll do my best. Um, Again, the function of the vent is twofold, right? To either let the nasty smell go up, or more importantly, give as the water is going down the pipe, give a place for some air to come in to replace that water that's going down. Um, and as I say, everything I know indicates that you've got to have this vent system in a correctly designed plumbing system. So the vent and the clean out are really performing two different functions. The clean out is for service access or maintenance access. The vent is there to separate you as the homeowner, from the smells of what's going on in your waste piping. Does that make sense? Oh, you're very welcome. But again, this one's probably a little hard to see in, I always forget to turn the pointer on here, right? But again, our plumbing system will have a combination of supply piping and DWV piping. All of that going on, much of it hidden inside the walls. So, you as a homeowner or a potential home buyer, right? There's certain things that you can see or certain things that your home inspector can see when they are inspecting the house on your behalf. But a lot of stuff you can't see. A lot of stuff you just have to trust was done correctly. Right, here's some pictures of this. Looks like a commercial project because it's right, here's our steel decking and some sprinkler piping, but this would be both PVC or CPVC or cast iron DWV piping, right? Cast iron would be this black piping here. You see in this case, they have these metal straps. In my case, in my older house, the cast iron is what's called the bell and spigot. So the piping all fits together. I should have, like next time I run this class, I was up cleaning out the attic over the weekend, and I looked at some framing details in my attic or in our attic. Our balloon framed 100-year-old house, and I was looking at the cast iron vent piping coming up through the roof. When I do this class again, I'm going to take some pictures of my house so I have more pictures to show what this stuff looks like. But again, if you walk outside your house or look at your neighbor's house, you'll see that vent piping coming up to the roof. And if you look at it in your house, you can look at the vent piping, and then you can, kind of visualize how that vent piping relates to where the plumbing runs for the various, kitchen or lavatory in your house. Yes, Nicole.
So when you were talking about your house, and the balloon framing, I have a couple of questions. Do you
Sure.
know, and I don't know why I didn't think of this before, but do you know that your house has balloon framing just because, sorry, my dog just decided to
That's
bark.
okay.
Um, do you know that um, you have balloon framing because you know about houses and the age of your house, and so it's an educated guess, or is it something that you can see or determine by looking at elements of the house? So that's the first question. And the second question relates to the piping that goes all the way up, like the vent stack, for example, or the vent piping. Does that change at all based on platform versus balloon framing?
I'll take them one at a time. In our case, we made an educated guess based on the age of the house. Um, but we also found that we had insulation, we had blown in wall insulation put into our house, I don't know, maybe 5 or 6 years ago now. And, um, we started, the insulation contractor pointed out to us the fact that we had balloon framing because they were able to install a lot of the blown in wall insulation from the attic. And then that blown in insulation would make it all the way down to the first floor. And in some cases, we had it coming out in the basement. So it was our hunch based on the vintage of the house and kind of confirmed by what we've seen in various renovation projects over the years. Um, Question number two, platform or balloon framing. Um, it's going to be, the plumbing, the risers, and the DWV are going to be about the same either way. Um, you're generally speaking not going to have, certainly, you're going to try to avoid having your supply piping in an outside wall, right? In this climate, at least, you want to keep it away from the outside wall so it doesn't freeze. So you're generally going to be in an inside wall someplace. So um, it's not going to matter that much whether it's platform framed or balloon frame. Again, you're going to have to, provide the provisions for that plumbing piping irrespective of what system that you're using. And again, for residential, right, your supply piping is going to be 3/4 inch, maybe 1 inch. So no problem fitting that in a 3.5 2x4 frame to 3.5 inch space. In terms of the DWV piping, I'm just looking at some of the sizes here. I think generally speaking, you're going to be probably 3-inch DWV piping, um, at least in individual stacks. It may get larger, down to the basement or the basement floor. But again, looking at this thing, right, I see 3 inches, the largest DWV piping size that I see in this example. So again, that's going to fit inside our 3.5-inch stud space. So we shouldn't have to make any special provisions in residential. And again, it's not going to differ that much whether it's platform framed or balloon frame.
Okay, thank you.
Well, you're welcome. So the other element of a plumbing system, right? We obviously have to have a means of producing hot water. So we can do that a number of different ways. Probably the most common would be a gas-fired tank type water heater. So again, you see a couple elements here, right? Here's our tank. This black piping coming in would be the natural gas supply. And here would be, I can't tell from the picture, but we're going to have a hot and cold hot and cold connection to the hot water heater. And by code nowadays, we also have to have an expansion tank to allow for the water that's in that hot water pipe and in the piping system to have someplace to go when it warms up and expands. And we have this heater has a pressure relief valve or a pop safety valve, right? If the pressure in this tank gets too high, then it's going to open up and relieve water down to the floor. So hopefully you have a floor drain nearby or someplace for that water to go. We can also do the same thing with what's called a tankless water heater. So instead of having hot water stored in a tank and losing heat, we can have a system that essentially heats up water on demand. So when this heater sees flow through it, it will light up and then heat that water up. The only thing that you typically need to keep in mind with a tankless water heater is there might be a minimum flow rate, a quarter GPM or half a GPM, right? There has to be a minimum rate that's required for the unit to know that there's flow, right? If you have a tank type water heater in a big family, if you're late getting up in the morning and your mom and dad or your siblings have all taken their showers before you and you're the last one to get up, you may end up with a cold or a lukewarm shower if all that hot water in the tank's already been used up. The other advantage of a tankless water heater is it's just going to keep on making hot water as long as there's demand. So it might be advantageous in that regard as well. Yes, Christoph.
So, is there a reason that tankless isn't more popular? Or at least to my understanding, I haven't seen it used a lot in houses I've been in. Is it really just cost and flow rate that kind of sway people one way or the other?
Yeah, I would say it's going to be cost, and I think it's also just custom and familiarity, right? Certainly every plumber knows how to do this. Lots of homeowners know how to do this, right? These are common and widely available and well understood. I won't say that this is a new technology because it's been around a while, but still, it's something that is not in as common usage as a tank type heater. So it's probably just familiarity. I would say over time, this will become more widely accepted. But usually what happens, unfortunately what happens, right? Your hot water heater springs a leak. You got water pouring out of the basement floor. You're like, oh my gosh, I got to get that taken care of, right? You pick up the phone, call the plumber. Plumber says, yep, no problem. I got a 40-gallon tank in the back of the shop. I'll stick it in my truck. I'll be over there in an hour, right? As opposed to, oh, I got to run around to the supply house and find the right kind of thing, et cetera, right? It's probably inertia as much as anything else that keeps that technology from being more widely adopted.
Okay, thank you.
Oh, you're very welcome. Yes, Ayada.
And then just, with the tankless, is it common that homes may have multiple tankless water heaters? Because I feel like I was camping somewhere and we had to like turn off the water heater, like when we were leaving this cabin house every day. And I think there was like one in the kitchen and then maybe one in the bathroom, but.
Yeah, I'll get to give me 2 more slides and I'll get to that. Yes, you could have multiple copies of this, but they may actually look like that, right? A small point of use heater, But yeah, you could have it split up into multiple copies of this. Right, so here's a gas-fired tankless heater. Again, how do we know that it's gas? Well, if, you know, there's what, along with the cold water and hot water supply, we have gas piping, and we have piping for the in this case it's probably intake and exhaust, right? So we have vent piping. We can do the same thing with electric. Right, here's an electric tank type heater. Right, looks about the same as a gas, except that there's no vent. And you see what I'm assuming this is the conduit coming in with the power to that. You'll get exactly the same, or the same as a gas-fired heater, except that it's electric is the source of heat and not natural gas. And again, I think of these as point of use heaters, right? Let's say we have certainly I see them more commonly in commercial sites, but we may have a sink or a fixture that's a long way from everything else. And if you want to make sure you get hot water right away, you could have this small tankless unit there, so the hot water doesn't have to go a long way to get from the basement water heater all the way out to this faucet. Or again, Ayana, in your vacation home, you might have something like this, as opposed to, you said you had multiple tankless heaters. It might be something like this. And yes, you want to, when you shut down your vacation home for the winter, you want to shut off the plumbing and drain it out so stuff doesn't freeze up.
Yeah, exactly. Those seem like a really good idea, actually.
Yeah, again, I think they are. I mean, again, I'm more used to them in a commercial property where you have, one sink or one something that's a long way away from everything else, rather than running all that hot water piping and HWR, hot water recirculation piping. Instead of running all that piping out to that one place, you can stick this device in there and save yourself some piping. So detail for construction, right? If we're going to have piping going through a concrete or masonry wall, we'll often sleeve that piping, right? We'll sleeve that piping to allow for movement or expansion and contraction, right? Especially the hot water piping is going to change in temperature as hot water flows through it, or there's no hot water flow, the piping is going to warm up and cool down. So there'll be expansion and contraction, and different materials expand and contract at different rates. Plastics, generally speaking, have what's called a higher coefficient of thermal expansion, so they'll expand more for a given change in temperature than other materials will. So you have to allow for that differential expansion, and typically you do that with sleeving. This is a little difficult to see on my slide here, but this is figure 13-5 on page 233. This is what's called an isometric drawing. So it's a little bit easier to see when it's in your book, but this is another way of representing the piping system. In this case, this is the domestic. This is the distribution or supply piping. You know, it excuse me, takes a little bit of losing my voice here. It takes a little bit of getting used to, but once you get used to it, it allows you to see better what is going on, right? So the way I'm interpreting this would be this line here would be a group of lavatories back to back with each other, right? Because we have piping going out in both directions. So just like the picture we saw of phase 2 of the plumbing installation, right? Figure 13-3 on page 230. Right, I said that was a commercial project where that piping might be in a wet wall, wet wall between, back-to-back restrooms. So this one looks like it's a set of back-to-back restrooms. This next line looks like the fixtures are just going in one direction. And then above it, this would be what's happening on the floor above. So my interpretation here, we have a commercial building with pairs of restrooms stacked on top of each other, right? So we have back to back, say men's and women's on the first floor, men's and women's on the second floor. So again, this is isometric is a way of representing or visualizing what's going on in a plumbing system. Kind of helps you see how things go together. And we could certainly do the same isometric for the DWV piping. Here's some plumbing symbols. Again, I would say these are typical, right? Every architect or every engineer is not necessarily going to use the same set of symbols. You would think that, oh, that should all be standardized, but when you open a set of drawings, if it's from a new architect or a new engineer that you haven't worked for before, or haven't looked at drawings for, you might want to look at the legend to make sure that you understand the symbols that they're using. And obviously we have codes that govern how plumbing systems are installed. We have our I code, the International Plumbing Code, so that will be the same family of codes we learned about early in the semester, the I codes, the IRC, the International Residential Code, or the IBC, the International Building Code. There's an International Plumbing Code. And again, it's going to talk about, what types and kinds of pipe can be used in different applications, where we need to put in traps and cleanouts, what types of fixtures are required, venting requirements, connections, leak testing, et cetera, et cetera. Right, we have, especially the DWV piping has health and safety implications. So the plumbing code is going to be, have a lot of things that relate to how we install a system that provides a healthy environment for the folks in that house. And again, in the trades, we have people that do this type of work, plumbers or pipe fitters, right? The work we just talked about tonight would be work that a plumber does. next week, in the next couple of weeks, we'll see work that electricians and HVAC technicians or pipe fitters do. So in Chicago is still a union town, so different unions have different work that they have jurisdiction over. But all this, these are skills that require, training and apprenticeship. I know at Triton we have a plumbing classes that we offer. We don't do anything anymore on pipe fitting or HVAC. I think we did years and years ago. But certainly we have plumbing classes, and we now have a plumbing lab, so folks in our plumbing class can learn how to put this stuff together. Any questions? Okay, we've gotten to the top of the hour here, so sorry, I heard a ding here. I don't know what the ding was. We've gotten to the top of the hour. Why don't we take a 10-minute break or so, and we will come back and we'll go through the questions on page 237. We should be able to do that quickly, and then we will break out and get back to our friend Marseille. So we'll see you back in a few minutes.